Okay, it's been requested that I do HRW94P028, the one where they're launching something and it lands on top of a cliff. So we're launching from the ground, but it lands on top of the cliff. We want, and they give us this angle here, and that's the same for everybody. They also give us the time it took for this to happen, and it gives us the launch velocity. Okay, I'm going to try and do this without numbers, and you put in your own your numbers wherever I put this stuff. So A says find H. This is easier than you think. So everything that has to do with height is a Y thing. So I'm going to deal with stuff in Y only. Okay, so Y, this is the Y stuff. I'm going to do it over here. Well, I start on the ground. So my initial Y is 0. I end at a height of H because, I mean, that's where I stop. I stop at that height above where I started, H. Okay, my initial velocity in the Y direction is, well, I've got this number. I have V0. I have that number, but I've got to break it up. So the Y component is that magnitude times the sine of that angle. I'm going to put 60 degrees. Okay, because everyone's got the same 60 degrees. You know what? Actually, let's just make it a theta. Just a theta. Theta. In this case, theta is 60 degrees. Whereas the x would be whatever the launch velocity was times the cosine of theta. Okay, so over here, I've got initial velocity in the Y direction was initial velocity times the sine of theta, both of which I know, so I could get a number for this. Okay, the velocity when I land, I don't know. That's the velocity in the Y direction of when I land. I don't know that. I do know the acceleration though. It's always gravity. You know what? To make it even more number barren here, I'm not even going to use 9.8. I'm going to use G. In this case, negative G, where G stands for 9.8. Oh, I always do that. No, go back in. Go back in. I don't know why I do that. It's happened like 5 times. Sorry. Okay. Where whenever you see G, that just means 9.8 meters per second squared. But running G saves me a little time and space. Okay. Back to this. And T, they give us. I'm going to leave it as a T though, but they do give it to you in your problem, so you have a number for that. Okay. I want H. This is good. I have everything I need. I've got initial velocities, I've got accelerations, I've got times. I can use the big equation, the standard equation. I can use this one. Okay, where Y is H. Y0 is 0. Let's see. V0 Y is V0 sine theta, leave the T, and then A is negative G, so I'm going to combine that. I'm going to put it up here and combine that negative, so I end up with G over 2 times T squared. All of these I know, so that will give you H, and you'll have H, and H will be done. So that is number A is done. Number A, yes, number A. Okay, number B. Number B says find V. That is the speed, the magnitude of the velocity where the projectile hits the cliff. So right here at point A. Okay, to do that, all I need are, let's see, B. Yep. To do B, I need the velocity in the Y direction and the velocity in the X direction at that point. Now that's too bad. I mean, that's not too bad. Vy is this one right here. So I have all the same information. I just need to solve for Vy this time. And luckily, I have initial velocity, I have g, and I have t, so I can use the short equation. So vy equals v naught y plus acceleration times time. So that's going to be vy equals v naught sine theta plus, well, actually minus gt, because because a is negative g. So let me just change that. Minus gt. Okay, all of these I know. All of these I have numbers for, so I could get a number out of this if I wanted to. Let's look at vx. Vx is actually easier. Because the x direction has no acceleration acting in that direction, the vx just stays whatever it was to start with. So it's v naught cosine theta. So I already know that. Which means that v is, should probably, yeah, okay. V is the square root of vy squared plus vx squared, okay, which is vy squared is this stuff, this stuff here, so the square root of, be a little more careful drawing here, v naught sine theta minus gt squared plus v naught cosine theta squared. All of these you have numbers for, so you can get your answer for v. That will be the answer, and so b is done. Boom. I should probably checking these off over here. Yeah. Okay, last one, find h, where h is the maximum height the projectile reaches. That is another y thing, but we have to use different numbers than the stuff in green here because this is a different problem. It's ending at a different place. So this is kind of like a new problem. I'm going to kind of, let's see, let's cordon this off a little bit. So I'm going to do this here. In this case, it's y again, so why not? Well, I'm still starting it on the ground. That's fine. I'm ending, basically, I'm only going to do this bit of the path from here to there, and then I'm stopping the problem. So the problem stops at h. So that's my position at the end. Okay, let's see. V naught y, well, it still started with the same velocity, so that's the same. V naught sine theta. V in the y direction at this place is actually 0. Now, the projectile is still moving, but it's only moving in the x direction. At this point, it is only moving like that. That's it. There is no velocity in the y direction, so I can say that Vy is 0 at that place. A is still negative g, but this time I don't know time. And unlike some previous problems that we've done like this before, the time they give you is the time just to go from here to here. This is not symmetrical, so I can't just cut that time in half, so I don't have time. Which means the only equation that I have that I can use is this one. V naught squared plus 2a, change in position. Vy is 0, so this is gone. I have this, that's going to be negative g. This is 0, so this is gone. And that we're going to replace with an h. Okay, and we're going to solve for h. So replace this with an h. And we're going to solve for h. So let's see. What we really have is 0 equals v naught squared plus 2a, where v naught is not just any v naught. It's the v naught in the y direction. So we're going to have to modify that when we get to it. Well, I want to get this alone, so I'm going to move this to that side. So I get negative v naught in the y direction squared equals 2ah. Divide by 2a on both sides. Okay, this is gone. So h is going to be negative v naught y squared over 2a. You might have v naught y already calculated as a number. I'm going to go ahead and put it in as without numbers again. So without numbers, this is how it would look. So negative v naught sine theta squared over 2 times negative g, so I get negative 2g which means these basically cancel out. It gives me h. So that will be a positive number in the end, which is good because we are above the ground, so it should be positive. And that gives us part C, and we're done. Yay!